This is the last lab that my students do before the AP exam. This is electrochemistry, and we're going to do electrolysis of a solution of potassium iodide. My students are required to do a pre-lab before this experiment. Their pre-lab is to predict the possible products of this electrolysis. In order to do that, they need to have access to a standard reduction potential chart. This used to be part of the AP exam packet. It no longer is. When it's needed, they'll give you a small section or just half a dozen important reactions. So students have to predict what is going to happen. And then I don't care what their prediction is. I only care if their prediction is reasonable. So they can't say, for example, well, when you electrolyze potassium iodide, you're going to get acetone formed, or you're going to get solid potassium formed. That is possible in some other universe, but it is not possible here. And if they show me that, I say, nope, go back and think about that. They've already seen from my demonstration what happens when you put sodium in water, and we talk about that whole experiment. Anyway, once they've gotten a reasonable hypothesis, they do the lab. And here it is. This glass thing is called a U-tube. I always have to pause for laughter there. The U-tube is just a U-shaped tube. You can get these for a few bucks. They're not too expensive, and they're not too delicate either. You could probably make them if you were enterprising. You could probably find something close enough to work. These hold about 25 to 35 milliliters, and I say fill it about 2/3, 3/4 the way full. Doesn't really matter. The solution on the right is not actually doing anything. It's just a dirty electrode. The electrodes that I use are just graphite rods. Any size will do. You can probably use a pencil lead as well if you want to scrape down a pencil and take the lead out, or break a pencil and take the lead out. We have a bunch of these from decades past. And the U-tube with the electrode sets up like this. You can see the 9-volt battery is the easiest way to get power. And you just connect the two leads. And one thing I like about this lab is it either works or it doesn't. You can see it within about 2 seconds or nothing happens. And in this case, you'll be able to see a little bit on the right side. That actually is the reaction going. On the left side, we're having trouble picking that up. So I might try taking my electrode out and seeing if I have a clean edge on the other side. A smaller electrode might work better. You get a different surface area ratio. You can sort of see that happening. It might be also possible these batteries are old, so I'm going to take a second one and put it in series. See if that gets a better reaction. Again, one thing I like about this lab is it either works or it doesn't. You don't have to wait and see whether your results are making sense. They either show up or they don't. This lab is mostly qualitative. So if it's 1 molar potassium iodide, that's great. If it's not 1 molar and you tell the kids it's 1 molar, it'll work just fine. I often will say, when we prep the lab, we're going to use potassium iodide and go through the whole predict your products, and then the next day the kids come in and say, oh, we're out of potassium iodide. I'll give you a few minutes to revise your hypothesis for our solution of sodium iodide. In reality, it doesn't make much difference. when I ask students in this lab analysis about the anode and the cathode, they have to really think about it. There's some kids who will say, oh, I did engineering or I did physics and I know the positive side or the negative side of the battery, whatever is which. And I say, you should know by what is being produced here. If you did your hypothesis correctly, you should know which side is the anode and which side is the cathode by what your products are for each of the half reactions. And this is essentially just an electrolytic cell. We don't need a salt bridge. We don't need a porous disc. We have a complete circuit, and this will go on as long as it needs to go on. I tell my students about 10 minutes, and then nothing's going to change. So whenever you're done, stop.